Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow guys, all that aside, let's get on with the show. Well, heidi ho, all fellow radio enthusiasts. It's your humble amplifier technician joining you here once again. This is a fully functional specimen of wonderful homebrew technology that we're going to cover here today, but we're going to shoot this from a different point of view. I get probably about 8 phone calls a week from guys that have bought equipment from eBay or QRZ or wherever, and they get it to their house, old vintage equipment like this. It's got glass bottles in it, tubes, and they get it to their house, they go put it together, and they turn it on, and the thing explodes. And then I listen to their story about how they got it and how they had one when they were a kid, or their uncle or their dad, their nephew, their best friend had something that inspired them to get it now that they finally are in a position where they can afford it, whatever. I hear their stories and I go, well, did you do this? No. Did you check for this? No. Okay, well, it blew up because of this. I want to go over and I'm just going to cover some of the things that you, the end consumer, should be looking at when you go and you purchase something like this, or any piece of tube equipment. I don't care who it's made by. You should take the time, do a cursory visual examination, and save yourself a lot of headache and a lot of trouble. We're going to use this as our example. I'm just going to go over it, and we're going to take a look at it from, okay, let's say in theory we took this out of the box, to, okay, now we're going to actually put power to it. There are a couple tools you're going to need. There's a lot of them. You're most likely going to need some screwdrivers, a voltmeter, and if you can do, please spend the money, go out and buy yourself a variable tap transformer, otherwise known as a variac. It doesn't have to be much. This is a 110 volt version. It's fused for 20. This is the most powerful tool. You can find variacs listed all over the place, from $30 all the way to $500. I've got a true 220 volt variac sitting over there in a corner. It weighs 1,000,000 pounds. I never use it. I even use this on 220. I'll probably explain how to set that up, although I'm a little leery too, because I know somebody out there is going to try it and then electrocute themselves and say it's my fault. But this is a powerful tool. A couple $100 to have in your ham shack, and it's going to save you thousands of dollars when you go to hook up, turn on, and play with your old vintage tube equipment, even stuff that's been sitting for 4 or 5 years. In most situations like this here, you want to turn it on slow. This will help. But for the most part, all you're going to really need is a screwdriver, a voltmeter, and a little bit of time. So let's go ahead and take this apart on the level to what you would normally receive something at, and we'll start from there. Before I start, I'm going to say this is the best reuse of Collins stuff I've ever seen in my life. This amp is cool. Friggin' cool. Okay, so now these are little tips and tricks that I've picked up over the years of working on things for people that have saved me a ton of time, a ton of energy, and a lot of heartache. And I'm going to pass them all on to you. So here we go. Okay. You've decided that you're going to buy yourself a vintage piece of tube equipment off the internet. First things first, you will insist that the tubes get shipped separately in a separate package, in a separate container underneath their own separate insurance. The cost of replacing tubes these days is such that the tubes need to be insured themselves for a minimum of $1,000. Okay, I don't care. In this situation, we're dealing with a pair of 4-400s. If they're 3500Zs, 250Bs, I don't care. The tubes need to be shipped separately in their own container, individually wrapped with at least 3 inches of bubble wrap around all the way around the tube. Minimum. This 4-400, I think, is around $300. So we put 2 into the equation at $600, then plus the time that you're going to be down without the equipment. Easily can come up with that $1,000 number, okay? If you receive your amp and the tubes are still in it, you're most likely going to have problems. The way they treat packages, especially heavy equipment like this these days, will hurt your mind. No one gives this many F's about your equipment. The only person that cares are the person that sent it and the person that's receiving it. Everybody else that's going to handle it doesn't care. Something heavy like this, I have wrapped in cellophane, then we have 2 inches of bubble wrap put around it, then we have it put in a commercial cardboard container, not the little shitty U-Haul bought at Home Depot containers. A commercial, it's like a 1/2-inch thick cardboard that is custom made for the box. Then that gets itself put in a piece of bubble wrap, then that gets put in yet another container, and then that goes in a wood crate. I would probably argue that I ship a lot of glass tube amplifiers from this shop. Probably, I don't want to say more than anybody else, because there's always one guy that does more than anybody else, but I've done a lot. Unless the seller is willing to package this 80, 50, 100-pound piece of equipment to that standard, do not buy it. I don't care if it's the only one you can find on the internet. I don't care if it's the only one you've only seen in 6-8 months, whatever, and looking. If the shipper is not willing to take on the responsibility of packing your equipment appropriately, you're never going to receive it to be able to use it in the first place. So let's say that you've managed to get the shipper to agree to actually giving a crap about the equipment that he's sending to you, and you get it on your end and nothing is damaged that you can see from the outside. You're going to have the tubes out of it anyhow to have them shipped. Take a minute, pull the data sheet, and let's go look at the tube. This is going to save you a ton of heartache. If the filaments are shorted out to the grids are shorted to the anode. If there's something wrong here, and we stick it in here and we turn it on, it's not only going to scatter the amplifier, but it's going to cause damage to a bunch of shit. Or if we just take a couple minutes with a voltmeter and ring it out, you're saving yourself a ton of heartache. Let's grab our voltmeter, just put it on diode check. We're not looking for any specific resistance. What we're looking for is hard shorts. So you're going to have 2 leads on this thing that are going to be filament. And they're going to be together. Or filament leads. Okay. If you touch to one of the filament leads and any of these other leads in turn and get a short indication, this lead, this lead, this lead, you've got a problem. Okay. Also in turn touch here to any of these leads on the bottom at all, you have a problem. Stop. Don't go any further. You have an issue. The tube has got a problem. Do not put it in the amp and try and run it. I've had people literally call me and tell me, well, I tried it on this end, but it was only shorted on 3 of the 2 pins, and I put it in there and tried it anyhow. I figured, well, it'll when I turn the filament on, it'll just made the problem go away. I don't know what planet they live on, but that's a separation of reality. We're going to take a minute. We're going to examine our pin legs. All 3 500Z amplifiers, 400 or 4-400s, that kind of thing, have soldered pins. The tube's assembled, then the base of the tube is put on, and then this is soldered in place. And what we're looking for is what they call drop solder. The pin will be hollowed out and there'll be a wire on the inside of it because the solder literally fell out of the tube. The tube got so hot in operation that the pin got so hot and the solder fell out of it. Take a minute, look at your tubes. You're going to hold this up next to your ear and you're going to do what they call the clink test to it, where you're going to slowly rotate the tube back and forth right next to your deaf ear. I'm 44 years old, I have tinnitus. Okay? Shot a lot of guns, been around a lot of loud stereos in my life. Had some really violent shit happen, hit in the side of the head a couple times. My ears ring all the time. I have tinnitus, just like everybody else, okay? When you get old, this was part of life. Hold this up next to your wife's ear. If there's any kind of tink, any kind of rattle, anything, stop. You have a problem with the tube. Don't put it in the amp and try and run it. Call me. Call somebody that's a tube expert. There are certain styles of ceramic tubes, like the 3CX 15, 20,000, 4CX 5,000, and so on, where there is a separator pin that rides on part of the flyback circuit, not flyback circuit, but can't remember the name of the specific piece on the inside of the tube. There's an insulator that slides up and down on the inside of the tube, and you'll hear it go stink, stink. That's different. What we're listening for is more like a very soft baby rattle noise. Tink, 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 tink. As you slowly rotate the tube around in your hands, you're looking through the glass, and you're looking for little pieces of metal or anything that could have fallen out of the tube. The filament cage that's on the inside of the tube, this is an open-based anode. The shit will fall out. Take a minute and look at your tubes. It'll save you a ton of energy. Now as we go forward, I'm going to show you another test. It's called the air bottle test. I've covered it in several YouTube videos, but it's absolutely important. It's how to check the tube to make sure the tube still has a vacuum on it. These older tubes, sometimes there's a little tiny micro crack that takes place up here at the anode or down where the pins are at. You got to remember, these tubes were made in the 60s and 70s. Well, 70, 80s, 90s, 2000, 2010, these are 50-some-year-old tubes, some of these things. They ain't as bright and shiny as they used to be. But if we're careful with them, we can still get a couple heads turned when we go to the ball with them, okay? So take a minute. Look at the color of the paint on the tube. Look at the, you know, if the tube is smoked out on the inside. These are all indicators that are saying, hey, this tube's either at the end of its life or it's having a problem. First and foremost, biggest tip. Wring out the tube with your voltmeter. Visually inspect the tube. Listen to it. And let it tell you what type of life it's had by just looking at the pins. Just looking at the pins will tell you what kind of life it's had. If they're really shiny, that means they've been in and out a whole bunch. If the solder balls that are on the end of the pins are deformed in any way, that tells you that this tube's been hot. That doesn't necessarily mean it's bad. It just means that it's something you need to be aware of. Look at it. Slow down and look at it. So we've looked at our tubes and we determined that they're satisfactory and there's nothing really majorly wrong with them that we can obviously see without putting power to them. Let's go ahead and let's start moving towards the point of let's hook it up and let's put power to things. Once again, a lot of the parts that are in here are 30, 40, 50 years old. Okay? If it has a socket, make sure it's actually in the socket and snug and the pins are making solid connection. Just go through, look at things. I mean, obviously we're going to have to identify before we go any further that we make sure that through looking at it with the meter and that we're going to isolate it by grounding it, that we have no high voltage present on anything, and then go ahead and stick your meat beaters in here. And let's go touch stuff. I mean, if it's silver plated, let's try and not touch it too much, but we're going to look around. We're going to touch wires, and we're going to look at our, choke, and we're going to parasitic choke. We're going to look at our plate choke. We're going to look at a bypass choke. We're going to look at the leads going to and from, make sure things are still very well connected, nothing is broken. We're going to look at our blocking choke, our other parasitic choke. We're going to look at one of our bypass chokes. This is going to come into play for very low in frequency, I guarantee you. And then we're going to look at all of the connections going to our tank coil. We're going to look at all the connections on our meters. If we have any burnt wires, anything that's broken in any way, stop. That has to be fixed before you go any further. Has to be. We're going to take and we're going to move all of our tuners fully. If there's a little piece of schmoo that has managed to jiggle down in here from shipping, we want to slowly look. Make sure all the fins, none of the fins should ever touch on any of our tuners. Ever. Never should they ever. If there's dirt, there's dust, there's grease, there's grime, well, that all has to be cleaned off. It might have worked for the guy that had it before you, but remember, we're trying to achieve this nirvanic state of bliss, which is called operation post-shipping. Shipping is such a violent process, especially with something that's very heavy like this. We have to look to see if the cabinet's been bent internally, the floor is bent. If the floor is bent, is it putting undue pressure on one of the tuners? It might cause the tuner to bend, cause the fins to arc. That means they're touching. Look, just slow down and look. You always want to identify where your plate transformer is at, your filament transformer is at, and then your filtering bank for your high voltage. This is the biggest Achilles heel to this older equipment, is usually the filtering bank. These are oil-filled cans. That means there's cans in here that's used as a dielectric, part of the dielectric process in the filtering. If these have any kind of leak, now we're not, okay, I cannot stress this enough. When your filtering circuits start to go bad, either they'll present themselves with, there's going to be what looks like it was wet at one point, but now it's dry and it's completely covered with dust and tacky schmoo. That means that can's leaking and you shouldn't trust it. You're literally trusting it with your life. Is it going to arc through the can, run to the cabinet, come out and shock you when you go to turn the high voltage on and kill you deader in hell? Don't know. Be aware. Slow down. Make sure everything is dry. Everything is clean. The other way that some of the filtering circuits will present themselves is as the electrolyte inside a can starts to come out, it'll dry, and it'll dry into a white, hard powder. It's really common with actual coax, or actual capacitors, like what's inside of a sweep tube amplifier. At the tips, at the ends of the capacitors, it'll look like dried toothpaste at the very ends of the caps. White toothpaste, dried, very dried. If you see that, don't flick it off with your finger, stop. Get on the internet, order that part, and replace that part with the exact same, not close, the exact same value component. If you try to run it, and you see the signs of the capacitor leaking, I guarantee you, you're going to hate life. Now, it might have worked for the dude 5 years ago, and then he put it aside, and now he's deciding to sell it. Did he hook it up and run it before he sent it to you? You know, if there's a problem, he's going to claim he did. The liability falls to you. You need to take a minute and just look at it. Visually put hands on things, touch, feel, smell it. When the caps start to degas and cook off from age, they smell, I akin the smell to something like old dried fish. Very pungent odor. It shouldn't smell like a whole lot. Maybe some old electronic smell, but usually when you smell that old electronic smell, what you're smelling is the caps outgassing. Just look around your amp deck, associate yourself with it. That gives you the opportunity to look at all the connections for your band switch. Now this particular amp has 2 band switches. Most of them that are commercially made are, well, they're hooked together, so there's one switch does the job of 2 things. Now this particular amplifier's got an old Collins plate transformer in it. Look at this thing. Old Collins emblem here. It's 0.565 amps. So roughly 1/2 amp at 2,250 volts on the secondary. It's got 2 taps of 110, 110. So technically this transformer could be run on 220. This one. I don't know about this filament. This does also look like a filament plate transformer out of a Collins as well. Look, touch, feel, smell. Look for any kind of residue coming out of your filtering circuit. Observe. Look at things. Look at the bottom of the porcelain. Look at your doorknobs. Make sure they're not cracked. Now, these are hard doorknobs. If you have the soft paper wax based doorknobs like what's on the side of SB220s, give them a squeeze. If they're soft, like bubble gum, replace them. Don't even try it. It's not even worth risking it. Just stop. Go get on the internet. Go buy and replace the doorknobs. If it's got a crack in it or a burn mark on it or anything, stop. Replace. Do not risk. Do not risk. So now we're going to stop and we're going to look at the bottom side of the deck. Whoever put this together actually cared. They really honestly cared. And they put this together with some love. I think that this thing is awesome. The construction of this thing is just absolutely wonderful in my opinion. Once again, we're looking for wires that have popped off, bad solder joints. We're going to take a minute and we're going to look to make sure we got disc capacitors. We're going to look at our filament leads, make sure they're not touching, nothing's rubbed through anywhere. We're making sure we got good solder connections here. The guy actually cared enough, he grounded the grids on this particular socket set, which I totally dig. This is our input network right here. Like I said, 2 band switches, one for the top, one for the bottom. So one for the input, one for the output. If we need to adjust our input tune, this is where you do it from. And I just think it's wonderful. Output glitch choke, got to make sure we got one of them. It's attached. We don't have any bad coaxes that are going to possibly arc out, burn through, explode, melt down, give us any kind of problems. Slow down. Look. Look at it. Don't just slam the tubes in it and get excited and like, oh, I can't wait to run it. Well, take a minute. Slow down. So now like this here, this is our high volt rectifying board. Look at that. That touches the lid. We have a problem, Houston. So we're going to get out our little flat blade screwdriver. We're going to turn this so it's flat, and then we're going to tighten down our ceramic insulator. Let's get our socket. Let's tighten this up as well. Remember, it's porcelain to plexiglass, so we don't want to get too awful tight. Good to go. Take a minute. Look. Visually look. This is part of our filtering circuit. This is our high voltage filtering circuit. We're looking around all of these joints here, the plate. We're looking at the aluminum, making sure that there's no corrosion. None of the electric schmoo inside of the capacitor has decided to find its way out and has leaked itself down to this cabinet. Because you know this is probably the longest this amp's ever spent upside down, unless it was shipped across the country like this at one point, which I know it wasn't. Take a minute. Gravity works all the time. So it might not necessarily run out on the floor of the amp on the top side where we could have seen it, but did it run out on the bottom side? No. We're looking for leaks. We're looking for bad connections. We're looking for parts that have popped off. We're looking for resistors that might have broken in half. We're looking for stuff that might shift and hit the lid of the amplifier or the case of the amplifier. All of these things will cause you to have failure, or either that or just death. I'm telling you, if you get an amplifier in that doesn't have a grounded plug on it, like this here, do yourself a favor. Cut the plug off and replace it. Ground the case of the amplifier. Give yourself a chance of living. Don't give yourself a chance to die because you're being lazy or cheap. This stuff is no joke. This will kill you, and it doesn't give a crap about you, your kids, your dog, your horse, your cars, your bills, your credit card, your debt. It doesn't give a shit about any of that. It'll kill you in a New York second, and it won't even pull out as it's doing it. Respect everything in here because it can kill you. But once this thing's sealed up inside of a metal box, as long as you've got a good ground, a good station ground, if something jumps to the cabinet, it's going to run to ground and not run to you and then try and find ground. That's the reason these two things are very important. We don't want you to get electrocuted. It's not worth it. It's just not worth it. slow down, visually look, make sure your relays are working well, and this is your opportunity to go in and clean your contacts on your relay. Another tool you might want to think about picking up is a varnishing tool. This is mine. I've had it for probably 14-15 years. This is given to me by the guy that owns our local CB shop way back when. This is a varnishing tool. Okay. It looks like a smooth piece of metal, but it is not. You can buy these for like $1, $2 on Amazon. Take this, put this between your leads on your relay and clean them. This here, slide it inside. That contact's clean. Light pressure, don't mash it down with your finger. Now that contact's clean. If you don't have one of these fancy dancy $2 tools, take a $1 bill that's crisp and new, fold it over twice and stick it in there and move it in a small concentric circle. The texture of the $1 bill is that so that it is enough to not score the surface of the contact too overly bad, but just enough to hone it up and make it pretty. Whatever you do, do not get out your fingernail clipper and stick it in there and start dragging this thing back and forth. Do not get Mama's emery board. Do not use 2000 grit sandpaper. You want to polish this up so it's smooth like glass. Not rough like I drug a file over it. Smooth. $1 bill or the actual tool for the job. Food for thought. Now what I was talking about earlier in the previous segment is this is an actual lead capacitor. See how the leads come out of the end of it? Instead of coming out of one end, they come out of both ends. When these break down and start to leak, you're going to see that they'll have shmoo either here or here where it's just wicked right out of the capacitor. So we're looking for any kind of residue, which we don't see in this amplifier. But just stop, take a minute, look. Do you know what you're looking at? It's the base of this amplifier. So again, like I said, this thing has spent its life sitting just like this on these four legs, and what we're looking for is data. And the data that it's going to give you is we're looking to see if anything has ever leaked out of the caps onto this board, onto this piece of metal. It'll show up. Yeah, there's a little bit of oxidization on this. There's a little bit of moisture that's accumulated in this thing in the last 5 decades since it was made. It could have been just that the guy never bothered to clean the aluminum before he threw it on here, but seeing the way that this thing was anally put together, I don't think that's the case. I just think a little bit of moisture got on the aluminum. But what we're looking for is anything that might have fallen off of any one of the capacitors. It's going to cause this to be discolored. Look around the inside. If there's any burn marks on here, where'd the burn marks come from? Take the lid, line it up, look, get out your flashlight, get in there, line it up, figure out what is arcing to the lid, what's causing a problem. That's fine. That's fine as well. Yeah. I'm perfectly comfortable running this. Okay. There's nothing here that's going to cause me to have any pause to hook this thing up and run it. I don't see anything. And when I mean hook this thing up and run it, I mean plug it into a variac and bring it on incredibly slow. We're going to cover that. Let me zip all the screws back in this thing because I don't need to be back in here. Okay. So we visually looked at all of our parts, made sure there's no burn marks on our plate chokes, none of that stuff's got any kind of problems. We've looked at everything thoroughly. The next thing we're going to do is we're going to set ourselves up for something called an air bottle test. I don't even remember the place where I learned this. I picked this up from somebody, but I've been saying do this test for a long, long time. think I might have picked this up from my friend 300, or not 300, but 77. You're going to insert your tubes into the socket, and you're going to just push them in so they're nice and solid. You're going to rock them back and forth just a little bit, make sure they're solid. Now, if you turn the tube on, or turn the amp on, and the tube doesn't immediately light up, don't freak out. 9 times out of 10 what it is that you've got a bad stab on the socket. The pins aren't making good contact with the finger stock on the inside of the socket. Just stop, turn the amp off, let all the high voltage bleed off, ground everything out, go back in, pull the tube out, stick the tube back in. 9 times out of 10 it comes back. If it doesn't, consider yourself lucky, because that way you know that the tube is actually bad and the finger stock, or it's not the finger stock issue, but your filament has gone to an open and it's not shorted to the grids and your amp isn't burning up. Just saying. The air bottle test consists of turning the amplifier on and watching the tubes, but without the high voltage attached. You take your high voltage leads and you're not going to attach them to the top of the tube. You're going to position them in such a way inside the amp that they're not close to the case, they're not close to any of the other components. There's no chance that it's going to arc or conduct to anything. Not the lid. Just move the high voltage leads away so that you have a safe space. Okay? Now promise me, if I show you guys how to do this, that you'll agree. We're going to have a gentleman's agreement amongst ourselves that we'll never run this without a lid on it. You never ever run your amp without it being completely closed up to where you can't get your fingers in there. Not once, not ever, not never. Protect yourself, safeguard your family. I mean, we don't have to put every screw back into the deck. We got to put at least a couple to make sure that this thing is safe. Safe for you to be around it, safe for the dog to be by it. I don't want to hear anything from anybody about, man, I was trying to do that air bottle test and I managed to electrocute my penis off. I don't want to hear it. I think I got the lid on backwards. So far, none of these sheet metal screws are stripped out at all. Let's turn this around. There, all the front holes line up. Now the top holes line up. Okay. So slap a couple screws in this thing. Make it so it's safe. We're going to contain the genie in the bottle, and the genie be in the high voltage. So we're going to secure our lid. And the next step that we're going to do is we're going to hook this up to our variac. And we're going to very slowly bring this on. But there's a little bit to it than that, just cranking and yanking it. Okay, we've got our lid all set up. Let's go ahead and set up for our next test. This test that I'm about ready to do holds true for anything that's got a vacuum tube attached to it. You can perform this air bottle test with any tube. If the tube loses vacuum at any point in its life, as soon as you light the filaments, the tube's going to turn white on the inside. It's going to fill up with white smoke, and the glass is going to turn permanently white-ish. It'll be like a dark gray. But as the filament's burning up, the filament's going to be reacting with the oxygen inside the tube. And that means you basically have a bottle of air. Because what we're looking for is a complete vacuum. Now, this amp is really cool that this switch here controls 100% of your high voltage. There is no low or high. It is on or off. That's all run with a little step start relay that's in here. Okay? We're going to light this thing for the first time with the high voltage off. This switch controls this indicator, which is RF and high voltage. RF, high voltage. We're going to flip this to the high voltage. We're going to make sure we got our band selectors in both positions that they need to be in. And this switch here controls an extra doorknob. And I think that's to help push it down for tune for like in the 80 megahertz. We're going to come back to that in another video. Have the lid on, have the tubes on, have the high voltage disconnected. Now, I have my Variac short fused. What I mean by that is the fuse inside the amp is a 5 amp fuse. The fuse inside of the Variac, 5 amp fuse. The Variac is in turn hooked to a power strip down here on a workbench, which has got a 20 amp breaker on it, which in turn is set to its own 15 amp breaker over in the panel. So we have the panel for isolation, we have the power strip for isolation, we have our variable tap transformer as isolation, plus then we have the safety fuse inside the amplifier. Quad redundancy. The first time lighting one of these things off, you're doing everything with one hand in your pocket, because you don't want to do this and this in the same breath. Now you're creating a pathway across your heart back to ground. Dead. Dead. We're going to go slow. Switch is on, high voltage reference is on, even though we have the high voltage neutralized. One hand. We're going to turn on a Variac, and we're going to slowly bring the Variac up. Now the Variac should go incredibly slow and smooth. It should be just as smooth as silk. If there's something inside of here that is shorted out and it's not happy, it's going to represent itself as resistance in this Variac, and you're going to feel it's going to make as you're trying to bring it up. Now we're going to start looking at the tubes. The tubes are starting to light up. You can see it through this window. Our fan's starting to turn, and we're all the way down at about 75 volts. We're going to very slowly turn this on. 110 volts. Now we're looking at our tubes. And we're looking to see if they light up. Now you don't want to do this test for very long. We're going to go ahead and we're going to back the Variac down and shut our tubes down again. We're going to turn the power off on the Variac, turn the switch off on the front of the amplifier, and unplug the amplifier. Now you're going to walk away. You're going to give it a couple minutes. What's this do for us, this couple minutes? Is that by chance there's any high voltage left inside this thing for any reason, we're letting the glitch, or we're letting the bleeders take that high voltage away, even though there's none indicated. Don't trust this meter. We verify. We verify. Now, unless you have yourself a high volt probe, you're going to have to trust this meter to a small smidgen. But once we open this deck up, you're going to ground it before you do anything else. Anything else. Disconnect the Variac. And this in turn is now the tops of these tubes are hot. The anode tops of the tubes are hot from temperature from the filaments running. We just want to turn it on, let the filaments run for a couple seconds, make sure the tubes don't fill up with smoke from the filaments burning up. That's called an air bottle test. You can do it for 572Bs, 811As, 813s, anything with a glass envelope on it. This test is valid. If you had high voltage that was present on the top of the tubes and you have an air bottle, you're going to have a high voltage leak, which is going to be catastrophic, and it's going to have to cost you. Your rectifier board's going to need to get repaired. There's going to be a glitch resistor someplace that's going to have to get replaced, and you could possibly damage your high voltage capacitors. That's the reason that this test is super vital, and I say please slow down, take a minute, and do this properly. It's going to save you a ton of headache in the future. Okay, so now we got to ground everything out. Disconnected. Off. Disconnected. Power switch off. Meter's reading at 0. I'm not telling you this is the safest way to do it. The safest way to do this would be to take and put a clip onto the cabinet, have yourself a chicken stick, which is something that's got a large, very known amount of insulated value to it, with a copper conductor on the end of it, and go dink and touch it in here. A lot of people aren't going to have that because they don't work on this stuff every day. We're going to assume, make the assumption that this is below 600 volts. And then we're going to hedge our bets in how we go about it, grounding out the circuit. Your common screwdriver has an insulated value, UL listed insulated value to 600 volts. Would I trust it at 600 volts? F no. This is Klein's idea of an insulated screwdriver, and this is supposedly good to 1,000 volts worth of insulation. It says so right here on the handle, 1,000 volts. But this doesn't work well for what we're going to do with it. There's not a long enough conductor. Assume, no, it's not dead and grounded until it's grounded. I taught that to me in line college and they beat it into my brain. It's not dead until it's grounded. Okay? So now we're going to come in here and we're going to work for a minute. Start that in by hand. Remember, with high voltage, it's not all about how tight you can make the fitting, it's about how much pressure you can apply over a large area. That kind of applies with low voltage current as well. You can have a good tight connection, but you need to have enough surface area to actually get the job done. Remember, we're only talking about 1/4 of an amp per tube, so. Okay. Let's go ahead and remove our clip, and now remove our clip from our case. And let's reinstall our lid. Okay, now we're going to bring this back up on the Variac a couple different times. Variac's plugged back in. Amp is now plugged in. Variac is at 0. We're going to turn on the Variac and we're going to slowly bring our Variac back on. There is no high voltage present on the top of the tubes because that switch is off. So verify that we have the same function that we did before. We've got indicator lights, our tubes are running, our fan is on. Let's go ahead and bring this back down. Let's bring our high voltage switch into play, and let's slowly bring this up. That's that soft start circuit I was talking about. See how hard and how sudden it came on? Let's go ahead and let's slowly start building our voltage. We're at 105. And now we're at 110. That needle's laid hard in the corner, isn't it? Relative RF power, high voltage. So now that we have all this stuff running, and we know everything is running, we have our high voltage present, we have our fan on, our filaments on, we don't have an air bottle test, nothing's arcing, nothing's burning up. Variac came on nice and smooth. There's one more test that we have to verify. Plate. We're going to look at our plate. We're going to take the thing into transmit. Please note how that jumped up a little bit. What we're looking for is to verify that we have bias and a 0 signal. There is no RF going into the amplifier. Back to 0. That's telling us that the amplifier has found 0 signal, it's got the right amount of bias on it, and the deck comes up. And we're just going to leave it keyed for a couple seconds. About 10 or 15 seconds. And we're waiting for the bottom of the tubes to, we're just seeing if it's going to stay at idle heat. There's this little bit of red here that's actually from paint from the iMac label that's on that tube. This is an iMac, the other one's a Penta. Doesn't really matter, same tomato, same tomato. If the tube doesn't flare, you're good. Now certain tubes like the 4-1000s and so on, they act a little differently. 3-1000s are a little different animal. For the 500, the 811As, the 250Bs, that kind of thing, you should be able to stand on the pedal with no drive, manually activate it, have 0 signal, and the tube not flare up cherry red immediately. You should be able to sit here at 0 signal for a long period of time before the tube's skirt inside the inside of the anode starts to heat. I don't see us having any problems. High voltage off. Leave the meter on. Now we're going to stand here and we're going to watch this needle. That should be fairly linear and smooth in how it bleeds off. It should be very consistent. It shouldn't be like click off completely down. It should be. That's what we're looking for. Once again, you see any of these things, tube flares up immediately, high voltage drops off right away, you have a problem. You have a huge problem. Now another way to make sure that this thing is done, well, this amplifier, the keying circuit is isolated unless the high voltage is on. That's kick-ass. Most amps, that's not the way. If you step on the foot pedal, it's going to apply a little bit of plate load to the high voltage, and it's going to pull that down to zero like that. I see it bleeding down nice and smooth. The tubes aren't flaring. This is where I would be like, okay, now let's go ahead and hook it up, and now we're going to try and make power with it. Well, that's the end of the tips and the tricks portion of the video. It's basically slow down, use common sense, look at it, think about what you're doing, take the next logical step, look at the tubes, listen to your tubes, feel the inside of the box, look at all the parts. Biggest tip is to make sure that if you buy one of these things off of eBay, that you have your tubes shipped separately underneath their own separate shipping label out of the packaging that this thing comes in, and with their own insurance. They're the weakest link in the chain. This amp is built like a tank. Heavy gauge metal, everything's bolted down very well. It's got star washers on everything. The gauge of the metal that the case is made out of is really thick. It's way screwed together. Like screwed. Everything is bolted with a lock washer on it. This thing, I don't have to worry about it falling apart and shipping for the most part. But at the end of the day, all of these things add up to having success. You can't just slam the tube in the amp, plug the amp in and flip it on and pray for the best. If there was a problem at any point, the Variac would have caught it. We would have made the observation with it. We would have seen it. We would have felt it. We would have heard it. We would have protected the amplifier. And all we would have had to do was either replace a tube or replace a component. One component. When it damaged any of the tubes, the power supply is not going to get damaged. There's a reason for this startup sequence. Never ever will we ever plug this in and just flip the switch and let it rip. This is old stuff, and it runs really good as long as you do these sequences of tests before you go and run it. Respect your equipment, fear and respect the high voltage, because it will kill you deader than dead. Like I said, it does not care anything about you, your life, your responsibilities, your family, anything. All it's trying to do is find a way to ground, and if that's through you, across your heart, or through one of your body parts, it's gonna go through it. No stick meat beaters inside cabinet until it's grounded, isolated, and grounded, and grounded, and grounded, and grounded. Hopefully this saves somebody's life. Hopefully it saves somebody a lot of heartache. Hopefully this helps somebody. Now we're going to go move on to the fun part of the video, which is going to be in the next segment, by the way, which I suggest you all watch. Let's run it and sell it. Gentlemen, I'll see ya. Hopefully I helped one of you guys. Bye-bye.